Alright guys, now what we discussed yesterday is when you draw the graph, okay, and then you differentiate it and draw the derivative. The derivative, so for example, is the derivative has to cross the axis directly below the max and min turning points. And the fact that it has two turning points means that it actually crosses the axis. Is everybody cool with that? So which one looks like that? B. How do you explain the answer? Well, it has two turning points. This means the derivative has to equal 0 at two different points. And the two different points where the derivative will equal 0 are directly below the max and the min. Is that okay? And that's how you explain it. You just write down exactly what I just said. Barry. Why is it sorry?
How do you know it's negative?
Oh, how do I know it's not the negative quadratic? So what we went over yesterday, Barry, is I gave you either, so you can do two things. You can go to your table function and make up a really simple cubic, and you can see there's a map the same way as this one. Then you put in a minus x squared plus x, and you notice that that one goes this way. So you know it's a positive x cubed and not a negative x cubed. Does that make sense? Now, I did say if you really want to learn it off, x cubed is max first, min seconds, and minus x cubed is min first, max seconds. If you want to learn that off by heart, by all means do it. I use the table function, draw a quick sketch to remember which one's which in the test. Okay? I don't trust my memory, it's getting dodgy. Now, next thing is when you differentiate an x cubed, you get a positive x squared, which is a u-shaped function. When you differentiate a negative x cubed, you get a n-shaped function. Everybody cool with that? Right. That's how we knew it wasn't that one, and it wasn't that one. Now, just while we're at it, does anybody know what a graph of C would look like? C being the derivative. How do I know C has no turning points? Because dy dx never equals 0. It has to cross the axis for dy dx to equal 0. So this means that its sketch will probably be one that's always increasing. And does this one have any turning points? Huh? In fact, I'm just going to go back. And what we wanted to show you earlier was that this function is always increasing no matter what. Correct? So what happened here is if it's always increasing, it hasn't got a max or a min, does it? Because it never decreases to have a maximum. So what we're thinking is if we draw the derivative cannot cut the x-axis because there's no place where the derivative would equal 0 because there's no turning points, correct? So what I would do is I'll draw the two of these right now. Will you take that one down as well, Phelan? You have the two of them? Yeah. Right, I'm going to draw these really quickly, and you will see that the second graph should not cut the axis, okay? So here's what we're going to do. Okay, what's the first one, Phelan? X cubed minus 6x squared, yeah. Plus 18x plus 4. Ouch. Alright, now that looks like nothing really, but if I drag it down, we'll see the graph in a second. It's always increasing, isn't it? There's no turning points, correct? What happens if I graph the derivative? What's the derivative? 3x squared minus 12x, yeah. 18. As predicted, the derivative does not cut the axis because there's no turning points. Ever cool with that? Right, that's a good one to show you, okay? You might need that someday. Now, draw a rough sketch of the derivative of each one of these. Right, let's start off with the one we know. Which is the one we know? We just did it a second ago, didn't we? The cubic equation. So what do you reckon? Sorry. It should cross the axis. If actually, you know what I can do is sort of be lazy here. I can just sort of sink it up underneath. Put that there directly underneath it. Now I can be really lazy. Now, see the minimum point? Go straight down underneath it. That's where it cuts the axis, yeah? See the maximum point? And Barry, is this a minus x cubed or a plus x cubed? It's a minus x cubed because the minimum coming first, okay? So that means my derivative is going to be n-shaped or u-shaped? Yeah, when you differentiate it, it's n-shaped. So therefore, it's going to be something like that. Go with that? All right. Yes, sir. I don't know. I could have drawn like that, Brian. It's just a sketch. Huh? No, not without the original equation. Not a chance. Just as a rough sketch. Okay. Now, the next one's an interesting one. Would ever agree the next one is a minus x squared variant? Okay? And when you differentiate a minus x squared, you're going to end up with a minus 2x or some minus x. Does that mean your slope is positive or negative? So what direction does that mean the line will go in? The line will go downwards. Now, where does the line hit the axis? Below D. So it'll hit it at 3. And it's a negative slope, isn't it? How negative, I don't know. Is it like that? Is it like that? I honestly don't know. Just make sure you have a negative slope going through. 3. Is that all right? Now, what's the slope of the next graph? Can anybody tell me? You can actually get the equation of this one. Who asked it there? Was it Brian? Brian, you can actually get the equation of this one because you actually know 2 points, don't you? Slope will be minus 1. Yeah? You can do the equation of the line if you wanted and get y on its own if you really want. But essentially, it is the line y equals minus x. Okay? Because it's minus 1x, isn't it? Where does it cross the axis? If you must know, I just use mx plus c. Crosses the axis at 1, checks the c value at 1, has a negative slope of minus 1, that makes that formula there, right? Now I'm going to differentiate that formula, what will happen? You get the y dx, which is the y value of the next one, equals. So essentially, your y value always equals minus 1. And what does that mean? It's a straight line going across at minus 1. Did anybody get that? Straight line going across at minus 1. Okay. So long story short, derivative of an n-shaped function is a negative line. Derivative of a u-shaped function will be a positive line. Derivative of a line will just be a straight line going across. Then you're done. All right, let's move on. What did I do? 6 and 8 so far? 10. All right, I'm going to be quiet for a minute. You guys have a look at this one first. This is a graph of the first derivative, okay? The first derivative is an x squared. Would you agree with that? So that means the original function must have been 1/3 x cubed. How do I know that? What happens when you differentiate 1/3 x cubed? You get x squared, don't you? So I know the original function must have been a max first and a min second, correct? And the max would be directly above minus 1. How do I know that? Yeah. And the min would be directly below 3. Find the x coordinate of the stationary point of each curve. Well, in the first one, it's x equals minus 1 and x equals 3. And we get that? All right. Find the range of x values for which each curve is increasing. No bother. Okay. When is it increasing? Let's use the highlighter. Increasing in yellow, decreasing in blue. So where is it increasing? Any value smaller than minus 1, it's on the increase. You're in the yellow zone. Any value bigger than 3, you're back in the yellow zone again, and you're increasing. Have I killed that? Yes.
How do you know, like, to use your own curve?
Because it says it's the slope function, so it is the first derivative of the original function. So it's the slope function keyword. Okay. Now, Daly, what do you think about the next one? B, yeah. So it's a minus 2x squared, okay? Is that right? So it would have been a minus x cubed to begin with. Now, when you differentiate that, what would you get? Minus 3x squared, wouldn't you? Now, 2 is 2/3 of 3x squared. Would you agree with that? So, what happens if we did it like this? What happens when you differentiate it now? What will it turn into? Exactly. It turns directly into that then, doesn't it? When you differentiate it. So the original function was a minus x squared, which means what, Barry? Max before min or min before max? Barry's saying this is a min before max situation, okay? So we're going to do min before max. And look, here's our 2 points for min before max, okay? There's your min. Okay, go up. There's your max. Drop it back down. We're going to have to estimate this. What do you think? 4.6 or 4.5? Minus 4.6 or minus 4.5? What do you think? Minus 4.5 is the x value. And what about the x value here? X equals 1. Now, where is it increasing? Blue is decreasing. The blue region is decreasing. The yellow region is increasing. So what does that mean? Greater than minus 4.5, but smaller than 1. If I want to write that in one go, how do I do it? Come on, Brian. How do you write this in one go?
Minus 4.5 less than x, x less than 1.
Good job.